Hello everyone, once again welcome to our physics class. Hope you all are fine over there. Children, in the previous few chapters we have talked about ways of describing the motion of objects, the cause of motion and gravitation. Another concept that helps us to understand and interpret many natural phenomena is work. Closely related to work, there are some terms such as energy and power. In this chapter, we shall study and discuss all these concepts. As you know, all living beings need food. Living beings have to perform several basic activities to survive. We call such activities life processes. The energy for this life processes comes from the food. We need energy for other activities like playing, singing, reading, writing, etc. So activities that are more strenuous require more energy, isn't it? Even animals are also engaged in many activities, like they have to fight for their food, their shelter, they need to fight and they need to move away from their enemies, like that. Okay, and also we human beings engage some animals to lift weights, carry loads, pull carts, etc. So all such activities require energy. So today we will discuss about work. We will discuss about energy in the coming sessions. So what do you mean by work? In our day-to-day life, we consider any useful physical or mental labor as work, but it is being defined differently in science. Okay, so what is work? There is a difference in the way we use the term work in our day-to-day life and the way we use it in science. To make this point clear, let us consider a few examples. See, consider a girl, Kamala. Kamala is preparing for her examinations. So she spends too much time in studies. She reads books, draws diagrams, organizes her thoughts, collects question papers, attends classes, discusses problems with her friends, and performs some experiments. So she spends a lot of energy on these activities. So we will say that she is working hard. But all this hard work may involve very little work if we go by the scientific definition of work. Even though we will say that Kamala is working very hard for her examinations, by science, by the definition of science, she is not doing any work. Consider another example. You are working hard to push a huge rock. Let us say the rock does not move despite all your effort. You get completely exhausted. However, you have not done any work on the rock as there is no displacement of the rock. Okay, so by the definition of science, you haven't done any work because the rock does not move even after applying the force. So you worked hard, but your work does not reflect in that rock. So by definition of science, you have not done any work. Okay. Now consider another example. You stand still for a few minutes with a heavy load on your head. You get tired. You have exerted yourself and you have spent quite a bit of your energy. Are you doing work on the load? By the definition of science, you have not done any work on the load, but you are tired. Okay, now consider another example. You climb up the steps of a staircase and reach the second floor of a building just to see the landscape from there. You may even climb up a tall tree. If we apply the scientific definition, these activities involve a lot of work. Why? When you climb up the steps of a staircase, there is a force and that force is acting in the upward direction because we are climbing up. And as a result of that force, there is displacement. You have reached the second floor of your building from the ground floor or from the first floor. So there is a displacement. Okay, so there is a force. As a result of that force, there is a displacement. So in terms of science, we can say work is said to be done here. And if you climb up a tall tree, you have applied a force. As a result of that force, there have some displacement. So by scientific definition, we can say this activity involves a lot of work. So in day-to-day life, we will consider any useful physical or mental labor as work. Activities like playing in a field, talking with friends, humming a tune, watching a movie, attending a function are sometimes not considered to be work. But what constitutes work depends on the way we define it. We use and define the term work differently in science. To understand this, let's discuss the next slide. So two conditions are need to be satisfied for work to be done in science. A force should act on the object and the object must be displaced. So from the examples that I have cited just now, you might have understood that two conditions need to be satisfied for work to be done in science. So which are the two conditions? A force should act on that object, and as a result of that force, the object must be displaced. If either of these conditions does not satisfy, we say work done is zero. Okay. And how will you define work? Work is defined as the product of force and displacement. So work is equal to force into displacement. This is the equation to find out work. If the formula to find out work is force into displacement, then what will be the unit of work? See, you know the unit of force is Newton, unit of displacement is meter. So force into displacement will be Newton meter, right? So the unit of work will be Newton meter, and another term for Newton meter is joule. Joule is the name of a scientist. So another name for Newton meter is joule. Hence, the unit of work is Newton meter or joule, capital J. So, how will you define 1 joule of work? See, work done by 1 Newton force in displacing the object to 1 meter will be 1 Newton meter or 1 joule. So, how will you define 1 joule? If you are getting a question like this, define 1 joule. How will you define it? This is the answer. Work done by 1 Newton force in displacing the object to 1 meter will be 1 joule. Okay. Then, is it a scalar or vector quantity? So, work is a scalar quantity. It has only magnitude. It doesn't have any direction. But we will use certain terms like positive work, negative work, like that. So, when do we say that work done is positive? If displacement is in the direction of force, then work is taken as positive. Okay, if displacement is in the direction of force, work is taken as positive. So, consider one example. Okay, so consider a bench. Now, you are standing here. You push this bench by applying a force in this direction. So, what is the direction of force? Force is applied towards this direction, towards the right direction. As a result of your force, the bench has been displaced towards right. So, here force is applied towards right. As a result of that force, the object has been displaced towards the same direction, that means towards the right. So, in this case, displacement is in the direction of force, then work is taken as positive. Okay, and in certain cases, displacement will be in the opposite direction of force. Then work is taken as negative. For example, frictional force. In the case of frictional force, the object will move towards one direction, but the frictional force acts in the opposite direction. Okay, so work done by the frictional force can be taken as negative. Okay, children. So, this is the case of positive work and negative work. Now, if if force and displacement are perpendicular to each other, what will happen? If force and displacement are perpendicular to each other, work done will be taken as 0. and no need to study more about this concept because it is based on a product known as dot product in mathematics. You are not studying that product in your class 9 mathematics. It has been discussed in the +1 course. Okay, so you just remember this concept. When force and displacement are perpendicular to each other, work done will be 0. Similarly, when force applied on an object is 0, work done will be 0. And even after applying a force, if there is no displacement, in that case also work done will be 0. So what are the cases of 0 work done? So 3 cases are there. Under 3 situations, 0 work done can be observed. What is the first situation? If force is 0, work done will be 0. Okay. Now, second case, if displacement is 0, you have applied a force, but as a result of that force, there is no displacement. For example, pushing a large rock or pushing a wall. Okay, just go and push the wall of your house. Does it move? Is there any displacement? No. So in that case, displacement is 0 even after applying a force. In such cases, work done will be 0. Now, third case, when force is perpendicular to displacement. When force is perpendicular to displacement, work done will be 0. Okay, so these are the 3 cases of 0 work done. So just remember the concept of positive work done, negative work done and 0 work done. So we can also consider some more examples for positive and negative work done. So consider this example. A person is climbing up. That means he is climbing up the steps. Okay, and he is carrying a load over his head. So when he carries a load over his head, he exerts force in the upward direction, and he is also moving in the upward direction because he is climbing up the steps. So displacement is in the upward direction. Okay, so here work done is positive because force and displacement is in the same direction. Now consider another example. The person carries a load over his head, and carrying the load he climbs down the steps of a staircase. So in that case, he exerts force in the upward direction because he carries the load over his head. So the force is exerted in the upward direction. But what is the direction of his displacement? Yes, he is climbing the steps down. So displacement is in the downward direction. So force is in the upward direction, but displacement is in the downward direction. Right? So here work done will be negative because force and displacement is in the opposite direction. Okay, now consider the movement of the planets around the sun. So here in the center you have the sun, and consider any planet, let it be Earth. Earth is revolving round the sun like this, right? Okay, so Earth is revolving round the sun. And in this case, what is the direction of force? We had already studied in the gravitation chapter, that is centripetal force acts towards the center of that circular path, because in any circular motion, centripetal force will be acting towards the center. And what will be the direction of displacement? See, if Earth is moving along this direction, then the direction of displacement will be like this. This will be the direction of displacement. So displacement is acting along this direction and force is acting towards the center. So what is the angle between force and displacement? Here the angle between force and displacement is 90 degree. That means force and displacement are perpendicular to each other. So in this case, work done will be 0 because force is perpendicular to displacement. Okay, so I hope you understood the concept of positive work done, negative work done and 0 work done. Also remember the unit of work. Unit of work is joule. So with this I am concluding my session. Notes of the topic and YouTube video have been uploaded. Just go through it. We will meet in the next session. Till then, take care all of you. Stay home, stay safe. Thank you.